Hello, good morning to all. In last lecture, we have seen region. In this case, region is nothing but a here. Region. Region is nothing but a it is a connected set. Connected set. Okay, and closed or open or mixing of these two. Mixing of these two sets. Okay? That means it may contain all boundary points or some boundary points or some boundary may be omitted. That means for this set, yeah, then such set is region. That in this case, we can count all sub-boundary points. Then I will it is a region. Okay. Therefore, this is important thing, but it must be connected set, and it must contain all or subs. Okay. Now we start our new point, that is nothing but a repeated or reiterated limits. Repeated limits. Okay. For function of one variable, we are having case for function of one variable. For function of one variable, we are having only one variable, and we'll write that is limit of f of x at point x is equal to a is limit x tends to a f of x is equal to some number L. L is some real number. In this case, we'll show here limit x tends to a is nothing but equals to f of x. It must be x tends to a plus, that is right limit of f of x, and it must be equal to left limit of f of x. Therefore, this limit is also then in this case epsilon is a real number is called limit of fx at point, okay, as x tends to a is if for given epsilon greater than 0, there exists delta greater than 0, such that such that such that such that mod of f of x minus l is less than epsilon whenever 0 is minus a less than delta. This will be the case where function of one variable. Okay. When we are having function of one variable. Now for function of two variables. Function of two variables. That means here we are having two variables, and now question arises here that whether to consider two variables at a time or simultaneously. Now for function of one variable, this can't be a case, but for function of two variables, this is important whether to consider one or two variables at a time, one by one. Okay, in this case, the both cases are permissible. That means we can take both variables one by one, or we can consider both variables simultaneously or one by one. Now we'll take here when variables are considered one by one. That means we are having here case that repeated or iterated limits. That is one kind of this one function of two variables. That is two cases. Two cases. That is variables one by one. Variables one by one, and such case is called iterated limits. Iterated or repeated limits. And first case and second case is nothing but simultaneously, both at time, both at a it is simultaneous limit, simultaneous limit or double limit. In this case, now we are considering here repeated or iterated limits. Therefore, we consider variables one by one. We will have here case first. That means variables one by one. Variables one by one. And in this, we are having two types. First one, that is nothing but we will consider x variable first and then that means first variable we are taking here limit x tends to a, then we are considering y tends to b of f of xy, and this can be said as L1, or this limit is L1. Then another case that means here we will consider y variable tends to b of function f of xy, and then x tends to a, that will be L2. That means here we are having two limits L1 and L2. These two limits may or may not be equal, that means they may or may not exist. If they exist, then question arises about equality of these two limits. Okay. Now here we are considering here for here that is your limit tends to AP, that is in R2. Okay. Now here note that both limits may or may not exist. May or may not exist. Okay. Then second, if exists, then they may or may not be equal. It may not be equal. And third case is nothing but, in this case, whenever we are considering one variable, we have kept another variable constant. Whenever we consider one variable, then in such case, another variable, or in this case variables are kept constant. Okay, these are kept. Illustrate these notes by some example. That is, both limits may not or may not exist. That is, first example in this case, that your limits may or may not exist. Okay. Limit may or may not exist. Okay. Consider a function. For example, consider a function. First example, consider a function f of xy is equal to sine of x upon y plus sine of y upon x, and this will be provided xy, this point is not 0 and is equal to 0 otherwise. Okay. Now in this case, if we consider such a limit, that is limit y tends to 0 of, and limit x tends to 0 of f of xy. Okay, therefore this will be simplified to y tends to 0, limit x tends to 0, f of xy is nothing but sine of x by y plus sine of hello. We'll see here that what will happen whenever x tends to 0, then what will happen when, okay, when x tends to 0, limit of sine of x by y is equal to 0, and limit x tends to 0 of sine of y by x does not exist. Does not exist. If this limit does not exist, this part does not exist, then whole limit does not exist. Hence, of limit x tends to 0 of xy does not exist. Similarly, what will happen if we consider another limit? And similarly, consider limit x tends to 0 of limit y tends to 0 of f of xy, f of xy. And then here in this case, limit x tends to 0 of limit 0 of sine of x by y plus sine of y by x. Then in this case, then in this case, when y tends to 0, limit y tends to 0 of sine of y by x is 0 and limit y tends to 0 of sine of x by y does not exist. Then here, what will happen? Here in this case, your both repeated limits, both repeated limits do not exist. Do not exist. Okay. Now we are having some examples here that is both limits does not exist. If we take one part and take another quantity and form a function, then in this case, your one limit exists, another may not exist. As will okay for that purpose. For that purpose, we will take a function for that purpose we will take that is example number 2. Consider a function f of xy equal to x upon y plus y, provided that y is not 0 and is equal to 0 otherwise. Okay. Then in this case, limit x tends to 0 of y tends to 0 of f of xy. In this case, limit x tends to 0 of limit y tends to 0 of x by y plus 1. Here, this does not exist. Does not exist. And limit y tends to 0 of limit x tends to 0 of f of xy is equal to limit y limit x tends to 0 of x upon y plus y is equal to. First of all, we take x tends to 0, therefore it will be only y. Only y remains. Because x tends to 0, y is y, and here your limit is 0. Seen that your one limit x does not exist, but that is very important example where one limit exists and another limit does not exist. Now consider third function where your both limits exist but they are not equal. For that purpose, we will take here f of xy in this way, that is x plus y, x minus y upon x plus y is equal to 0. Then in this case, what will happen? That here limit x tends to 0, that is x minus y upon x plus y. Therefore, this will be limit y tends to quantity x minus y upon y, and therefore such value is minus 1. Okay, such value is such value will be minus 1. Okay, this value will be minus 1. No problem. Now consider, okay, now purpose uh, for another things here, what will happen? Okay, then we consider another function. Okay, consider limit x tends to 0 of limit y tends to 0 of f of xy, and this will be limit x tends to 0 limit y tends to 0 of x minus y upon 0, therefore it will be x, that is this will be limit x tends to 0 upon, that is 1. Now here for this example, both repeated are not equal. Here both repeated limits exist and are equal, but not equal. But not. Now consider example number 4, that we are having a function where both repeated limits exist and are equal. Consider a function f of x y is equal to xy. Only xy, don't problem. Nothing more problem. Or you can take x plus y, also no problem. Then in this case, x tends to 0 of limit y tends to 0 of f of xy is equal to limit